So far, we've looked at two different ways of solving quadratics. One's a quadratic formula, which always works, and one is by factoring. We're also going to look at solving by square roots. Okay, and all that means is that just like when I have an equation like x plus 2 equals 5, to solve for x, I need to get rid of the 2 by doing the opposite operation, which would be subtracting 2 from both sides. So I would get x equals 3. Now I've got x squared equals 16. Well, the opposite of squaring something is square rooting it, so I'm just going to take the square roots of both sides. So now x equals 4. But we have to be careful. It's not just 4 because, yes, 4 squared is 16, but negative 4 squared is 16. So my answer is going to be a positive negative 4. You could write it like this with your plus or minus, or you could say a negative 4 and a positive 4. But you have two solutions. Remember, your quadratics can have no solution, one solution, or two solutions. All right, so you've got to be looking to see if you can get 2. Oops, don't know what happened to the second one. It's supposed to say 2x squared minus 5 equals 15. Alright, so I'm going to do the same thing, but I've got to slowly work my way to get x by itself. So first I'm going to add 5. Always work from farthest away from your variable. So I've got 2x squared equals 20. And then I'm going to divide by 2. So I get x squared equals 10. And then I'm going to take the square root of both sides. So I've got x squared, x. Now, the square root of 10, 10 is not a perfect square, and if I try to make a factor tree, I'm going to have 2 times 5. There's nothing I can take out because I cannot break this radical down. So my answer is going to be the square root of 10. Okay, now keep in mind, this is two solutions, because if I take the square root, I'm going to have a positive and a negative. You don't have to always write the positive negative out front, but it's not a bad habit to put that out front. Okay, so that you make sure you know there's a positive and that there is a negative square root of 10. Okay, sometimes when we work through and solve for square roots or we use our quadratic formula, we end up with a negative under the radical. So far, up until this video, we've just said that there's no real solution. Well, this is where imaginary numbers come into play. So an imaginary number is this I, we represent it with an I, and the definition is just that I squared equals negative 1. Okay, if I squared equals negative 1, I can take the square root of both sides, and I equals the square root of negative 1. Okay, so anytime we have a negative under my radical, that means I'm going to have an I somewhere in my expression. So now we're not just going to stop and say there's no real solutions. We're going to keep going and simplify to find the imaginary solutions. All right, so a couple of things about I. I to the 0 power, just like anything to the 0 power, is 1. I squared, I skipped one. I to the first power, right? Anything to the first power is itself, so that's just I. I squared is what we set up here. I squared is negative 1. I cubed, right? I cubed is the same as I squared times I to the first, which we said I squared is negative 1, and I to the first is I. So that gives us negative I. And I to the fourth is the same as I squared times I squared, which is negative 1 times negative 1, positive 1. Okay, once we get to I to the fifth, we start repeating. Okay, I to the fifth would be I to the fourth times I. Right? I to the fourth is 1. Anything times 1 is itself, so that one would just be I. So anytime you're working on simplifying your imaginary number, you always divide your exponent by 4, and whatever the remainder is what you have, is what your answer is, whether it's going to be 1i, negative 1, negative I. Okay, so if I have I to the 30th. Okay, 30 divided by 4 is 7 and some change, right? It's the same as I to the 28th times I squared. So here's my 4 times 7. Well, this is going to be the same as I to the 4th. It's just going to go away because it's 1. And then 1 times I squared, well, I squared is negative 1, so I to the 30th is negative 1. You take whatever your remainder is after you divide by 4, and then that's going to fit one of my options. Okay, another example, I to the 13th. Right, I to the 13th, the biggest number that 4 goes into would be 12. And that's going to leave one I left over. Well, I to the 12th, that one's going to become 1. And so my answer is just I. Right? I to the 7th. The biggest number, the biggest 4 goes into it one time. So that's I to the 4th, and that's going to leave 3. I to the 4th becomes 1. I cubed, we said, is negative I. So just some properties of I. When we use I, okay, anytime you have the square root of negative 1, that's just going to become I, and then we're going to simplify everything like we have been. So let's start by simplifying the square root of 24. Okay, there's no negative in there, so this is just like what we've done in class thus far. So 2 and 12 goes into 24. 2 and 6 goes into 12. 2 and 3 goes into 6. I'm looking for groups of 2. So I have one group of 2's. I'm going to take 1, 2 on the outside. That leaves 2 and 3 on the inside. So this simplifies to 2 root 6. Now I've got the square root of negative 24. Okay, so that negative tells me I'm going to have to use an I. So to do this, all I'm going to do is make this negative 1 times 24. I'm going to go ahead and take that negative 1, put it on the side. Okay, because I have a negative 1 over here, that leaves positive 24 to break down like we just did. So I've got 2 and 12, 2 and 6, 2 and 3. And I'm going to keep going. I got my group of 2's. I can't circle anything else, so I'm going to put a 2 on the outside, and that's going to leave my 6 on the inside. Okay, but I left this gap here because anytime we have this negative 1, that means I'm just going to put an I on the outside. Okay, so the square root of negative 24 just simplifies to 2I root 6. So it's still an imaginary number, but I was able to simplify it farther. So the square root of negative 15. I'm going to put my negative 1 times 15. Try and break down 15. I got 3 and 5, and those are primes, so I can't go any farther. So I have nothing to circle that I can take out. And I've got my negative 1 here. So on the outside, I'm just going to have an I, and on the inside, my 15, because I can't break that down anymore. The square root of negative 20. Got a negative 1 and 20, 2 and 10, 2 and 5. Looking for groups of 2, I have 2 2's. Okay, so I've got a 2 to take out. I've got my negative 1 here, which means I take out an I. And I have 1 5 left over. So the square root of negative 20 simplifies to 2I root 5. So now I'm going to solve, and it may or may not be positive. So if I want to solve for x, one option is to subtract 4. So x squared equals negative 4. Take the square root. So I've got x equals the square root of negative 4. Well, this is the same as I times 4. As negative 1 times 4. Get ahead of myself. I know the square root of 4 is 2, and I know that if I have a negative 1, that's going to become an I. Now you have to be careful because the square root of negative 4 is plus or minus 2I. X squared equals negative 5. Take the square root of both. So x equals 5, I know, is as simple as it gets. I can't take the square root of 5, so I've got a negative 1 and a 5. That just means I'm going to put an I on the outside, leave my 5 on the inside, And don't forget your plus and your minus. And finally, we're going to use this whenever we're working with our quadratic formula. So let's say that we've plugged this in, and I've worked my way down to this far, but I got that negative. Normally I'd stop and we'd say there's no real solutions, but now we're going to keep simplifying. So the square root of negative 24, we just did that one and said that that one was 2I root 6. Right? We just simplified that in the example prior to this. Okay, so I can rewrite this as negative 4 plus or minus 2I root 6 all over 2. Well, now I know that 2 goes into 4, 2, and 2. Okay, this whole thing, this I root 6, I can't simplify that anymore. It's going to stay. It's kind of like a variable. But I can simplify and take 2 out of all of my other numbers. So negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. So I'm just going to put my I root 6. And the 2 divided by 2 on the bottom becomes 1, and I don't have to write that. So my original negative 4 plus or minus the square root of negative 24 all over 2 simplifies to just negative 2 plus or minus I root 6.